Good morning students. Back to haloalkanes. Before starting for today's session, I just want to give a small recap of what we have seen till now. Till now in this chapter, we have seen what are haloalkanes, what are its classification, that is classification based on number of halogen atom, classification based on hybridization. Then we saw how to prepare halogen atom. In that we saw two important naming reaction like Frankenstein's reaction and Schwarz reaction. Then we saw physical properties, we saw chemical properties. Under chemical properties, we saw Wood's reaction and Sandmeyer's reaction. Then we saw haloarenes, how to prepare haloarenes, what are the physical properties and chemical properties. Under chemical properties, in haloalkanes what we saw? Nucleophilic substitution we have seen. Then we saw how to hybridize carbon atom. Then we saw reaction with metals. What happens in haloarenes? In haloarenes we have seen nucleophilic substitution based on hybridization. Then instability of phenyl cation. Then reaction with metals. In that we saw important reaction like Dow's reaction we have seen. So we have seen a complete pack of haloalkenes and haloarenes. Haloalkanes, nucleophilic substitution. Haloarenes, electrophilic substitution, which is coming under reaction of metals. I need to take S1, SN1, that is nucleophilic substitution 1 and nucleophilic substitution 2 for haloalkenes, right? Only that is pending in haloalkenes. We have completed all others. We have seen preparation, physical property, chemical property done. In haloarenes, we have seen preparation, we have seen chemical properties, electrophilic substitution done. So what is pending in haloalkenes? SN1 mechanism and SN2 mechanism is pending. Apart from that, polyhalogen compounds, we need to see 4 polyhalogen compounds. Then since this chapter is about halogen containing compounds, how to detect them, what tests are available to detect them. So with that the chapter will be completed. So what is pending children? SN1, SN2 mechanism, then test to detect the compounds having halogen compounds. Then we need to see polyhalogen compounds. So what is left out? We have left out some important definitions in between. We have seen the introduction part completely. What we have to see, that also I have told you. Then what is remaining, that we are going to see in today's session. Yeah. Stereoisomerism. Okay, what are stereo? I have already explained about this in class 11. How to remember about stereoisomerism? What are isomers? Isomers are nothing but 2 or more compounds having same molecular formula and same structural formula. Then what is difference? S for S. They differ in spatial arrangement of atoms or groups in space. Is called as stereoisomerism or stereoisomers. What are stereoisomers? They are 2 or more compounds. They are isomers. Isomerism exhibited by 2 or more compounds having same molecular formula, having same structural formula, but they have difference in the arrangement of atoms and groups is called as stereoisomerism. This property, the compounds which are exhibiting stereoisomerism are called as stereoisomers, and this property is called as stereoisomerism. What is plane polarized light? Plane polarized light. See, a beam of light having oscillation or vibration, this is confined to only one plane. Okay. How to obtain plane polarized light? You have to pass your monochromatic light through a prism. What is monochromatic light? Single chroma, single wavelength light done. So I am just explaining about plane polarized light. How will you obtain plane polarized light? Pass a monochromatic light through a nickel prism, you will be getting plane polarized light. It's nothing but a beam of light whose oscillations and vibrations will be confined to only one plane is called as plane polarized light. Moving to the third definition, optically active substances. What are optically active substances? The substances which rotate the plane polarized light when they are passed through a solution is called as optically active substance. So what are optically active substances? These substances should rotate the plane polarized light. When they rotate the plane polarized light, when they are passed through a solution. This property is called as optical activity. Okay, that is optically active substances rotating the plane polarized light when passing through a solution. This property is called as optical activity, and the substances which exhibit optical activity are called as optically active substances. Then what is optical rotation? Optical rotation is a property of rotating plane polarized light either towards right hand side direction or towards left hand side direction is called as optical rotation. So what we know, what is optically active substances, we know what is optical activity. Now what is optical rotation? Optical rotation is a property of rotating a plane polarized light either in clockwise, that is towards right hand direction, or towards left hand direction is called as optical rotation. Suppose if the plane polarized light is rotated towards right, what did I call them as? Dextro-rotatory, which is otherwise indicated by a positive sign. Suppose if the plane polarized light is rotated towards left hand side, what is that called? It is called as levo-rotatory, which is indicated by a negative sign. So clear? Till now it is clear. Now what is specific rotation? What is specific rotation? The number of degrees of rotation when the concentration of an optically active substances should be 1 gram per centimeter cube and the length of the polarimeter should be 1 decimeter for sodium vapor light. I am repeating, what is specific rotation? Specific rotation is nothing but number of degrees of rotation. How many number of degrees of rotation you are getting? From whom you are getting? You should get it from a sodium vapor light. Okay. Then what should be the length of the polarimeter tube? The length of the polarimeter tube should be 1 decimeter. And the concentration of that optical active substance should be 1 gram per centimeter. What is the required temperature? 25 degrees Celsius. Okay. So in short, I am going to indicate specific rotation by the term alpha, where alpha is equal to, this is what I told you, that is observed rotation by length of polarimeter tube into concentration of a solution. What we have explained in theory, I have written in the form of an equation. So what is specific rotation? It is nothing but observed rotation to the length of polarimeter tube into concentration of the solution. How much the concentration of the solution should be? It should be 1 decimeter cube. I mean, it should be, the length of the polarimeter tube should be 1 decimeter cube, and it should be a sodium vapor light. The temperature should be 25 degrees centigrade, and the concentration of the substances should be 1 gram per centimeter cube. Okay, this is how you have to represent the specific rotation. See, so I told you this in specific rotation, while expressing specific rotation, the wavelength of a substance should be represented as subscript. Oh, you know what is subscript, I'm super. So the wavelength should be represented in subscript. And what about the temperature, children? The temperature should be represented as superscript. Okay. So while indicating your specific rotation, you need to follow 2 rules. What are that? You will be representing the wavelength in the subscript and you will be representing the temperature at the superscript. Say for example, if I see this particular expression, that is alpha. What is alpha? Specific rotation. What is this? Wavelength of light. This is wavelength of sodium vapor light when it is in D form. And what happens to the temperature? The temperature should be 25 degrees Celsius and the specific rotation is minus 2.25, and the concentration, they have given the concentration as 0.50 in ethanol solution. So this is how the specific rotation should be expressed. So what is specific rotation in simple terms? Specific rotation is nothing but observed rotation divided by length of the polarimeter tube into the concentration of the solution. Okay. Moving to the last one, that is asymmetry. What is asymmetry, children? You know, asymmetry is nothing but I have a carbon atom. Just a minute. See, I have a carbon atom. This carbon atom is surrounded by 4 different groups. Am I correct? See, the carbon atom C is surrounded by A, B, C, D. Means what? They are surrounded by 4 different groups. If they are surrounded by 4 different groups, then there is no symmetry. So they are asymmetric, right? So a carbon atom surrounded by 4 different carbon atoms, then there is no symmetry. They are said to be asymmetrical. They are said to be asymmetrical. Then what is the purpose, or what is the specialization in being asymmetrical? Only when a particular compound is asymmetrical, it is responsible for optical activity. We know what is optical activity. When there is optical activity only, optical rotation happens. When optical rotation happens, then specific rotation happens. So this is how. So what we have seen, stereoisomers, S for S. So difference in spatial arrangement, clear. What is plane polarized light? You need to have a beam of light where oscillation and vibration should be confined to only one plane only. Done. How will you obtain plane polarized light? Pass it to a monochromatic. Pass a monochromatic light through a nickel prism. Done. Then what is optically active substances? They should rotate the plane polarized light to any one of the direction. They should rotate the plane polarized light. When they will do this? When they are passed through a solution. What is optical rotation? Should rotate in clockwise or anti-clockwise, towards left or towards right. If it is right, dextrorotatory. If it is left, levorotatory. Done. What is specific rotation? The definition, that is observed rotation by length of the polarimeter tube into concentration of the solution. What you should remember? Here the wavelength should be represented in subscript and the temperature should be represented as superscript. What is asymmetry? Carbon atom surrounded by 4 different atoms, then it is not showing any symmetry. It's an asymmetric molecule. Whenever it is an asymmetric molecule, then only it is responsible for optical activity. Then only it shows optical activity. Yes, children.